So now we're moving on to lesson 7. Lesson 7 is where we move into our new three-dimensional shapes. Prisms and cylinders should have been reviewed for you from grade 8 or grade 7, depending on your curriculum. And now we're going to move on to what should be some new three-dimensional shapes, pyramids and cones. So we're going to start with pyramids. And we always start with prisms because prisms and pyramids are related. And if you look at the diagram we have here, where we have this pyramid, it's a pyramid because it has a polygon base, but there's only one of them instead of a prism having two identical bases, and it comes to a point at the top. Now, you can see that this pyramid would fit inside the prism right beside it. And it would fit inside the prism, and it would go from the bottom right to the top. They are a match. They're a set. Now, you can see what that looks like over here in a more professional version. And what we find out is that the volume of the pyramid is exactly 1/3 the volume of the same prism. Ooh, my apologies. 1/3 the volume of the same prism. So a prism with the same base and the same height. So in this case, if it's a rectangular prism, the volume is 1/3 length, width, height. This is for rectangular based pyramids. So I'll put in red. The volume of a pyramid is 1/3 the area of the base times the height. So remember, area of the base times the height, or area of the base times the length, is exactly how we defined the volume of a prism. So any prism, doesn't matter what the base is going to be area of the base times the height, and the pyramid with the same base and the same height is just 1/3 of it. So let's do a calculation. So the base here, okay, so the area of the base, and this is the base, I'm just going to make that blue, is 8 times 10, which is 80, and it's inches squared. That's how I write that, inches squared. And the height is 6 inches. So the volume is 1/3, 80 times 6, which is 160, and we had inches squared times inches, so we're going to get inches cubed because volumes are three-dimensional. So you see, we found the area of the base, then we found the height, multiplied them all together just like we would in a prism, and then we divided by 3. This next example doesn't have a rectangular base. It has a triangular base. So the area of the base in this one is going to be 1/2 base times height. And this is base, and this is height of the triangle. So I'm going to put height base. I'm going to put a little subscript to show that I'm not talking about the height of the pyramid. I'm talking about the height of the triangle itself. So let's calculate that. 1/2, that's 12, and then that was, I wrote over it, I think it was 10. So that should be 60, oh, not inches, this one is centimeters. Centimeters squared. So I have the area of the base. So the volume is 1/3 area of the base, which is 60, times the height of the actual triangle, which is 17. And that's going to be 20 times 17. Which is 340 centimeters cubed. So it's always the same thing. Find the shape of the base, use the appropriate formula for area, multiply it by the height. And now remember how we said that cylinders were secretly just pyramids? Well, it's the same with cones. Cones are secretly just prisms. No, I have that backwards. Cylinders are secretly prisms, cones are secretly pyramids, and it's the same here. We can imagine that this cone is inside a cylinder. And the volume of the cone is exactly 1/3 the volume of the cylinder. Which is 1/3 area of the base times the height. Doesn't that look exactly like the pyramids formula? Well, it is. It's just instead of the area of the base being a polygon, now we have a circle. So area of the base is pi r squared because it's a circle. In this case, r is 3, so it's pi times 3 squared, which is 9 pi. I'm just going to leave it with pi for a second. Then I'm going to do the volume is 1/3. Area of the base is 9 pi, and the height is 7 millimeters. I can cross those. That's going to give me 3, so I have 3 pi times 7, which is 21 pi. Now I'm going to work it out. 21 times pi is 65.973, 65.973. I have only one digit in my question, so I'm going to round that to no decimal places. I'm going to round it up to 66 millimeters cubed, like that. And all of, oh, you guys can't see that, 66 millimeters cubed right there. All of your cones and pyramids are all the same. They're all just the exact same way you'd calculate the cylinders and prisms. Then you divide it by 3.